Okay, rule number 7 says moving a takeoff point beyond a summing point. Sorry. Moving a takeoff point.
सर ये हमने शायद पढ़ा ना.
I think नहीं, ahead of summing point हमने पढ़ा था कि नहीं?
तो beyond.
to आठ rules पढ़े थे हमने.
हमने 8 पढ़े.
What was the last rule?
Moving a takeoff point ahead of summing point.
Okay, so we'll start 9th then. Sorry, मुझे confusion है फिर. Sorry. Okay. Let's move to the rule number 9 then. It's rule number 9. Okay. So rule number 9 is interchanging two summing points. Okay, rule number 9 is interchanging two summing points. How we get interchanged? Let's see. Let's say this is one of the summing point and this is another summing point. Okay. Then okay, let's say these are the types of signal. This is a plus and minus. This is a plus and plus. It can be anything, but just for the example's sake, I'm taking this. Now what we have here, input is X and output is Y. So here Y will obtain up to here, it will be X minus X is positive, Y is negative, X minus Y. Let's say here we have Z. So plus is X minus Y and plus is now Z. So final output will be X minus Y plus Z. Now we need to exchange the summing points. So this little block diagram can be put equivalent. I will copy this because I don't want to repeat it. Let me copy this. Okay, copy and I'm going to paste it here. Paste. Okay, this will be equivalent to, I'll just manipulate it. See, now this summing point, sorry, this summing point has to come here. What's the objective? Objective is to bring this summing point here. Here. We need to exchange the here, here. And this we need to bring it to here. So we have to exchange the places of these two. So let's see how we can do it. Now what's the input going to this? X. This input is plus and plus. Leaving the input first. So what I can do here, I will make this thing. Okay. Let me draw the new one itself because it's not big enough to manipulate this. Should have been drawn big enough. Okay, anyway. Okay, now Let me draw this. This is the first I have to bring this summing point. So let us say this summing point is here. Okay. And this is the second summing point. Okay. Now, first summing point, what was the signals? Plus and plus. So I'll be using the same signals, plus and plus. No, this exchange, this should be plus and plus. I am bringing plus and plus. Here plus, here plus. This plus minus. I'm not changing anything, plus minus. But at the end of the day, I have told you integrity of the circuit shall not change. That means output should remain as it is. So that we will make sure. So let me put the signals. Sorry. This is the first. This is here. This is going to output here. And this is here. And this is here. This is all signals we have. Now in second, what we have? In second, we have Z here. Okay. Now, because we are exchanging, the input is not going to change here. We are bringing this summing point to this point. So it will bring its own signal Z, but X signal is going to remain there. So this is X. So here we are going to get output as X plus Y. Now this X plus Y will be input here. Now this summing point we are going to bring here. This signal it's not going to bring. It's going to bring this signal with itself. That is Y. Okay. Sorry, it's X plus Z here. Sorry. Output is X plus Z. X plus Z, both are plus signals. Now here it's going to input as X plus Z. This is minus Y. So this can be written as X plus Z minus Y. So this is the way to exchange it. It's same as X plus Z. That is the same as X minus Y plus Z. It can be also written like this. So this is the way to exchange the summing points. So inputs, the main inputs which are coming, they will remain there. But what's the attached signal to them? Sorry, what's the signal to them? That is going to change. That you have to exchange to the other place, and make sure that whatever the overall output of the block diagram is, that should remain the same. That should not change. That means integrity of the circuit at any point of time will not change. Okay, next is eliminating a forward loop. Rule number 10. Eliminating a forward loop. So let's say how we can eliminate this. Let's say we have two block diagrams like this, and we have a summing point like this. Okay. Sorry. Okay. Now let's say the input here is X. We have to eliminate this forward loop. And this we know, this is the first transfer function G of S. This is the second transfer function G2 of S. And this is plus minus. This is a forward loop going towards this summing point, and the output signal, let's say, is let's say y. So what is simple to eliminate the forward loop? Simple is this x, we can draw this equivalent of this as very simple forward loop we have to do. So this will be together one transfer function, and we have an input signal going to this, and we have an output signal going from here. So input signal is going to remain x, output signal is going to remain x. But how this is going to positive, this is forward loop going to negative. So this is g1 of s minus g2 of s. Or I will write it like this. I will make a big block diagram. Let me a bit big. I will make it. Okay. So input signal as it is, output signal. So this is G1 of S, forward loop will be eliminated minus, because this is going to there and this is going here. It's not a feedback loop. This is a forward loop. Very important. I have to identify these. Why? So this is the equivalent of this rule number 10. Very simple forward loop. We have to eliminate like this. Rule number 11. There are two rules in 11. Rule number 11A. So we have A and B, two loops, two rules for this one. Let's see what are these rules. Now let me draw again the block diagram. Sorry. Okay. This is your summing point. Okay. Input signal, error signal from here, output signal. This is, sorry. Okay. So this is, let's say this is plus, and this is plus minus. Okay, this is C of S, output signal. This is transfer function G of S, and this is a feedback loop H of S, and this is an error signal. So rule number 611 says what? Eliminating of a summing point in a closed loop system. What is this? Eliminating of a summing point in a closed loop system. Let's see how we can do this. Add a page here. Okay. Have a look here. Now this is a closed loop system. So we can write from above block diagram. See up to here. Take one by one. Up to here. This is output. This is input. It's error signal. We know that. This is what? Input going to summing point. Okay. Then we have error signal as a result of, because I will tell you, there's a input going to summing point, transfer function, then output. Actual output will get here, but Once that will be compared, that actual feedback will be given to the summing point. Here is the error detector that will see the difference between the actual output and the desired output. The difference will go here, and that will be error signal will be generated, and that will be forwarded as I have told you to do the necessary action. So in this case, we have to eliminate this what closed loop system completely. So we know up to here is output is this, input is this. So we can write C of S, sorry, C of S divided by E of S is equal to transfer function G of S. And also, this is let's say called equation number one. Also from this, we can get E of S will be equal to ESF. We can also obtain CSF, C of S by G of S. Let's call it 1 dash because we are obtaining the same equation from here. Now, what is GS here? Everybody knows that forward feedback path transfer function, back path transfer function, and H of S already told you what is this. This is feedback path transfer function. Okay, now have a look here. Let's say this signal here is B of S, input going to this. So we can see from here B of S, this is now from this here, have a look here. In this case, this C of S is going input towards this loop, and this is output. If you see signals from here, input, and this is output. Okay, so C of S is input, output, that is B of S by C of S is H of S. So we can also write that B of S, sorry, B of S divided by C of S is equal to H of S. Very clear. Second equation. Okay. Now let's go to the output of the summing point. The output of the summing point is given by, you can have a look here. Now see here. Now we are here somewhere. Sorry. We are here summing point. Now output of the summing point of EFS. This signal should be RFS plus and then plus minus BSF. So we can write EFS output as RFS coming to this, that's a plus sign, BFS coming with plus minus sign. So we can write this here. So we can write EFS is equal to RFS plus minus BFS. Let's call it equation number 3. Similarly, EFS, this EFS we can write also. CF, EFS is equal to what? CFS by GFS. So we can write EFS as CFS by GFS. Already we know from equation number 1 dash, we have got EFS, CFS by GFS will be equal to RFS plus minus. Also we know BFS. BFS will be written as HFS into, so I will write it here. BFS will be equal to CFS into HFS. So we can write it 2 dash. So from 2 dash we can get BFS also. That will be CFS into HFS. So let's call it equation number 4. So these are very clear equations. Error signal we have got. What are the coming signals towards it? We have added them. Nothing we have done. So then we have replaced the value of E of s and B of s. Okay. Now let's simplify the equation fourth for the overall transfer function. So from equation fourth, the overall transfer function, overall transfer function denoted by, you can see here, overall transfer function denoted, we can write that, let's say we will denote that by overall transfer function denoted by m of s. Let's say this is arbitrary we are taking, is given by overall transfer. CFS by GFS we are writing as m of s. So we'll write, sorry, not CFS, CFS by R of s, overall transfer function. M of s is C of s, that is complete output of the loop, G of s. We can, sorry, this is R of s. Overall transfer function we are talking about, this is C of s by R of s. This is overall output, this is overall input. That's what we are writing. C of s by R of s is equal to this formula. We know that formula, we have to derive it. This, let's not derive it, let's see what it will come. So let's derive from here. लिखने की जरूरत नहीं है. M of s हम बाद में ले लेते हैं. So it is given by, let's see how we can do it. So we can write from above equation, C of s by G of s will be equal to, so we'll again repeat it, R of s plus minus C of s into H of s. So this is fine for us, R of s plus C of. So now from here we will multiply the right hand side with G of s. So we'll get R of s multiplied by G of s plus G of s into C of s into H of s. So we have multiplied this by G of s. Okay, from equation fourth we are getting this everything. So what I am trying to do, I will bring the C of s here. So common term will come out, C of s. So 1 will be here and this term will be G of s. Sorry, this is plus minus here. Yeah, not mistake. This is plus minus in the equation. So when it will come here, other side it will go minus plus. It will become minus plus. Minus plus what? C of s is common. So it will be G of s into H of s. Okay. So this term, right hand side term will be only one term, that is R of s into H of s. So because my aim is to get C of s by overall transfer function, overall output divided by overall input, that is C of s by R of s, this can be written as C of s by R of s. So I will put this as, okay, sorry. Okay, how come R of s will be there? Sorry. This will be G of s here. R of s will come out. So when we take out this here, will be plus minus G of s, H of s, C of s is common, this term. Here will be left R of s, G of s. Here, sorry, G of s, H of s. Sorry. Okay. This term will come here, sorry. So this is, yeah, this is R of s plus H of s, fine. No problem. So now C of s by R of s will come here.
तो GFS होगा ना RS के साथ.
G of s, that's what. Just a second, this. Okay, this is R of s, G of s, fine. This is R of s, G of s. So I will bring this R of s here. C of s by R of s will be G of s divided by, sorry, divided by 1 minus plus g of s into h of s. So this is overall transfer function. So whenever you have to write overall transfer function for a closed loop system, that means closed loop system is what? There is a transfer function and feedback is going to the summer again. This is called a closed loop system. So you should always remember this formula. This is the formula now you have to remember. You should always, sorry, let me put it by red. This is the overall transfer function. That means g of s 1 minus plus g of s h of s. This is the rule number B for this one is rule 11B. So similar to this rule, can say, not similar, but it can be extended from this rule only. Now, if the loop is unity feedback loop, so let me copy this now. Okay, let's copy this. Sorry, copy. Let's paste it here. Okay. So now in this case, what I will do, I will remove this. There will be let's say it's a unity feedback now. Unity feedback means there is no feedback h of s. H of s is equal to 1 now. Can write here that h of s here is 1. That's called this is also called, if h of s is equal to 1, the name given in literature is a unity feedback loop. Unity feedback loop we can write. So let's solve this one. So in this case, what's going to happen? You can see RS is input, JS is output, unity feedback. So instead of H of S, we'll be putting 1. That's all. The formula will be amended as C of S, in this case, divided by R of S will be equal to G of S divided by 1 minus of plus G of S. So there's a bit amendment when the when there will be a unity feedback loop. So a bit we have to amend. That means HFS we have to put it equal to 1. And if you want to draw the same in the block diagram, you can also draw the same in the block diagram like this, where the input signal will be R of S, output signal will be G of S. So this your R of S, this is your C of S, output overall output. Then here you can write G of S divided by 1 minus of plus G of S. So this is overall block diagram you can make. So I think we'll finish rules today. Then we will do the numericals next time. So what is the rule number 12 now? I think this is the last rule. This is the last rule. Rule number 12. These are all block diagram technique reduction rules. So we have to see them properly. Once again, you have to go through them and then we will solve. We can reduce the block diagram. So when two or more, what is the rule saying? When two or more inputs on a system, when two or more inputs acts, it is acts on a system, the total output is obtained by adding the effect of each input separately. What does that mean? That means that we have to use superposition principle. We have to use the superposition principle. Let's see. For example, we have like this. This is a summer, and there is a block. Summer, we have this, and signals are like one signal is coming from here, another signal is also, another input is also coming from here. This is going, and this is the overall output of the system. So let's say this is R1 of S, this one input, another is R2 of S. That's what we are saying when two or more inputs act on a system. So what's going to happen? Total output will be obtained by adding effect of each. That means by superposition principle we'll apply. This is plus, let's say, and this is plus also. And this is G of S, and this is C of S. Okay. Now let's see what we can do. We will take one by one. One of them we have to make it 0. Another, so we'll take one by one. So what will happen? Now first we are going to take R1 of S, make this R2 of S 0. It will remain G of S, and it will remain C of S. Second, let's copy this. Paste. Okay, so second we have to consider R2 of S and make R1 of S 0. R2 of S, and this input here will be C1 of S, this will be C2 of S. Yeah, it should be like that, because inputs and that is outputs are going to change. Uh, Output will change when one of them will make to 0. So C1 of S will be equal to what? Output divided by input is, so output will be transfer function into R1 of S multiplied by G of S. Okay, similarly, C2 of S will be equal to output by input will be R2 of S multiplied by G of S. Okay, so total output using the superposition principle, let's say total output is C of S will be equal to effect of C1 of S plus effect of C2 of S. That will be C1 of S is R1 of S into G of S, and this will be R2 of S into G of S. So whenever we have situation like this where we have two or more than two inputs, then in that case what you can, then in that case what you have to do, you have to take each input and kill the other. Killing means that you have to make other one 0. Once you make it 0, see the effect of that first input which we have taken in the overall transfer function, get the result of that and add it to the, similarly we have to do for the second one and add that result. So this is to be highlighted. This will be, we will use this in the numericals. So I think today we'll close here because we have Salah also. Okay. So anybody has any doubt? Okay, Tanzib, you can send your what you call
Sir,
it?
layer on layer.
Yeah, log.
हो गया सर.
Okay, thank you. You can leave, no problem.
अस्सलामुअलैकुम सर।
वालेकुम सलाम।
सर आपने वो लेक्चर्स ये पोस्ट नहीं किए थे फिर यूट्यूब पे?
नहीं,
सर मैंने
मुझे हमें
परसों।
वाईफाई में घर में प्रॉब्लम था। ठीक है,
जी सर।
घर में वाईफाई में थोड़ा प्रॉब्लम है, वो भी ठीक हो जाएगा तो आई विल अपलोड इट। जितने
सर
मैंने अपलोड किए उतने तो देख लो आप।
जी सर, 7 और 8 मिस हुआ था बस ट्रांसफर फंक्शन का, तभी मैंने आपको मैसेज भी की थी सर, आप अपलोड
हाँ,
कीजिएगा।
करेंगे अपलोड। मेरे घर में थोड़ा वाईफाई का प्रॉब्लम था, आज वो बंदा आ रहा है
कोई
तो
नहीं
विल
सर,
सी इट। ठीक है,
थैंक यू सर।
कोई बात नहीं। स्टॉप द रिकॉर्डिंग।